All right, let's continue with functions domain. So we're going to do a situation where we have a whole. So we're going to find the domain. For y equals f of x equals x minus 3 over x squared minus 9. Now, you can actually factor this. You could write this as x minus 3, and then the denominator factors into, oh, my bad, x plus 3 times x minus 3. Now, this x minus 3 cancels in some way. All right, but we're going to write it a little bit special. We're going to write it as 1 over x plus 3, and that's if x is not equal to 3. And it's undefined if x equals 3. Okay, now, what I want you guys to notice, here, this expression is also undefined when x is not equal to, or when x is equal to negative 3. But I don't write that. And the reason is because from this expression I can see it. Okay, from this expression I can see it. And so I don't need to write it down. The reason I need to write it down here is that when I cancel these x minus 3's, in some sense I've lost information. And that lost information is really this line. Okay? Let's draw the graph of that to show what's going on here. So, if I drew a graph here, okay, at 3 I'm going to have some issue. I know that for sure. Also, at negative 3, I have a asymptote. Let me move this over here. Okay, so now what's going to happen? Now, when x is 0, I'm going to get 1/3. So let me put that line here, or that point here. At x equals, when x equals 3, this value is going to give me 1/6. So at 1/6, I'm going to have an open circle there. Okay. Okay, I'm going to have an open circle there. And my graph is going to look like so. On the other side, it's going to look like so. This looks very similar to the 1 over x graph, actually. Okay, but it does have this hole here at x equals 3. Okay, and that's what this is indicating. Okay, so the domain here, let me write it out in interval notation, is negative infinity to negative 3, from negative 3 to 3, and then from 3 to infinity. Remember what these parentheses indicate. So this is all real numbers, but we've thrown out negative 3 and 3. Okay? Let me write that plus or minus better. All right. Okay. Next thing we're going to talk about is what's called the difference quotient. These are important for calculus. So if you plan to take some sort of calculus, you will be doing some difference quotients at some point. Okay? difference quotient is defined as f of x plus h minus f of x over h. And what it is, or what it represents, is let's say you have some function. Let's say we have some function y equals f of x. Okay, let's say this is x, and this is x plus h. What you're going to find is you're going to find actually the slope of the line connecting them. This was a bad example, but it'll still do. Okay, so the slope is, remember, the change in the y's over the change in the x's. And these two x's are only h apart. Okay? So as an example, let's find a quick one, or an easy one. And then we'll do a harder one. Find the difference quotient for y equals x squared. Okay, and actually we need to cancel until we get rid of the h. So part of it is we should do algebra until the h simplifies. Okay, so let's take the difference quotient for y equals x squared. I don't know why I just did that. We're going to take x plus h squared minus x squared over h. Now we're going to go ahead and FOIL this out. So x plus h squared is, remember, x squared plus 2xh plus h squared minus x squared over h. This x squared and this x squared cancel. This x squared and this x squared cancel. So we're going to get two xh plus h squared over h. And this is one place where we do allow ourselves to do the simplification. So we're going to factor out an h in the numerator and get 2x plus h over h. Now, these h's are going to cancel. So we're going to be left with 2x plus h. Okay, and we don't worry about h being equal to 0. We don't worry about that just yet. Okay, let's do another one. All right, let me find a good one. Let's find the difference quotient for f of x equals 1 over square root of x. Okay, this one's a little bit trickier to set up. So it's going to be, remember, f of x plus h minus f of x divided by h. Now in this case, our f of x is 1 over square root of x. So our f of x plus h is 1 over the square root of x plus h. Okay, so I'm going to write this as 1 over h times 1 over square root of x plus h minus 1 over square root of x. Okay, so notice this is the f of x plus h. This is the f of x, and they're divided by h. So multiplying by 1 over h is the same as dividing by h. Okay, let me move that over here. Move this over here. Okay, now we're going to have to do our algebra magic. 1 over h. Now, we have to add fraction, or actually subtract fractions here. What's our common denominator? Our common denominator is the square root of x plus h times the square root of x. So this term over here is missing the square root of x. So we're going to have the square root of x over square root of x plus h minus this term here is missing the square root of x plus h. Okay, let's do a little, running out of space. That's not good. I can make space though. That's one of the things I like about teaching like this, is I can make space if I need to. Alright, made some space for us. So now we're going to take this equals, we still have 1 over h. Now we're going to have square root of x minus square root of x plus h over square root of x plus h. Now I'm going to show you guys a little trick here. You remember the difference of squares, but if not, let me remind you. A squared minus b squared equals a plus b times a minus b. Okay. Now we're going to do the same thing, but sort of in reverse. I'm going to take the square root of x minus the square root of y times the square root of x plus the square root of y, and let's multiply that out. Okay? So if I were to do that, actually let me change the order. You can see it follows the same pattern, right? Square root of x is a here. Square root of y is b. So, square root of x plus square root of y times square root of x minus square root of y is simply x minus y. You could multiply that out as well, but it's just something I want you to sort of get used to seeing. Okay, so here we're going to use that. So here we're going to multiply on the numerator and denominator by square root of x plus square root of x plus h. Okay, so what are we going to get? We're going to get 1 over h in the numerator. X minus x plus h over square root of x plus h times square root of x plus square root of x plus h. Okay, now we just have a little bit more mathemagic to do. 1 over h. Here, in the numerator here, the x's cancel, right? X minus x. And we're just left with a negative h. And now, finally, these h's cancel. So we're left with negative 1 over square root of x plus h times square root of x plus square root of x plus h. Wow, that's a mouthful. Okay. Let me see if I can make that a little bigger for us. Yeah, it looks good. All right. Okay. All right. I'll see you guys in the next video.